I've been doing Android since 2009 with the very first Android phone that was released, so the HTC G1. I had that. I think in other markets it was called the HTC Dream. So I love Android. I love Firebase. And it turns out, if you love Android and you love Firebase, you can get started with Android Things very quickly. Android Things is Google's Internet of Things platform. It is basically just Android, but modified slightly to work on very limited devices. What I like about it is that it's Android. So as a Android developer that's been working with Android since 2009, everything I know about Android is applicable to writing code for Android Things. So this is the kit that I use. So usually when you develop for Android Things, you have a development board. This is a development board called the Tyco IMX7. It's made by a company called Technection. I think you can order them online, and what you get is a board. And this is basically just the guts of a phone. This is how you can think about it. It has inputs for I/O, audio. There's a way to hook up a touchscreen to it. But the most important part is the 40-pin expansion headers along the top. Those pins allow you to hook up peripherals to this. This is where it becomes much different than a phone. A phone you don't plug in peripherals to it. It is its own device. With Android Things, you can plug peripherals into it. The peripheral that I had that was given to me is called a rainbow hat. So this mounts right on top of the board and it hooks into those 40 pins. With the rainbow hat, now you can play with these, so that you can think of it as a collection of peripherals. So there's multicolor LEDs, temperature sensor, buzzer for making noise, a display, 3 buttons, and there's breakout pins for even more peripherals. So now you can plug in servos and other types of devices and control them using Android. So there's a lot of different types of peripherals you can hook up to it. I'm a software guy, I'm not a hardware guy. So if you ask me about hardware and you start asking me about all these peripherals, I actually don't know that much. I think the person who's speaking after me will know more about peripherals. But you can do, just as a quick summary, there's GPIO, which is just things that are on or off, like buttons or LEDs. They're very easy to control. There's pulse width modulation peripherals for things that have a varying level of control, like servos and speakers and some kinds of LEDs. There's also integrated circuits. So if you're hooking up some more complicated devices like sensors or displays or microphones, you can you can write drivers for those using Android Things. And going even further, there's asynchronous and synchronous bus type peripherals for even more complicated types of things. So like GPS and printers, RFID readers, all these things can be embedded into a small device and controlled by Android. Now, usually, well, since I'm a software guy and I'm not a hardware guy, I'm not interested in writing drivers for all of these devices. I would rather have a driver delivered to me. So in my Android code, I typically just use drivers that were provided. So here's a series of drivers that work on that rainbow hat. So what it does is it gives you an object-oriented interface to work the things that you've plugged into your Android thing. This is much easier than trying to write the drivers yourself. Although some people really do love to write drivers, but I'm not one of them. Like I said, I'm a software guy. I want to write Android code. I want to write Android apps. So when the kit is assembled, it looks like this on my desk. So you can see there's a touch screen hooked up through a ribbon cable. There's a camera that's also hooked up through a ribbon cable, and there's a Wi-Fi antenna. You can kind of think of this like a broken out phone with extra peripherals. Usually what you do is if you're building something for Android Things, you prototype with something like this, and then what you ship to your customers is completely different. You work with an external company to build a device according to some specifications. So this is good for playing around, testing things, just experimenting, but the actual device that you would ship to customers would be quite different. And if you want to build your own hardware, you can do that as well. Now I look at this and I get kind of scared because, like I said, I'm a software guy, I'm not a hardware guy. So as soon as I see something broken up like this, and with like an oscilloscope and all kinds of like soldering irons, I don't know what I'm doing here. But you can do this if you want. So with Android Things, the implication is that you have an Internet of Things. So we know what the things are, they're the devices, but where's the Internet part? Well, the implication is that if you have Android Things, they should be talking to each other. There should be an internet. They should be connected devices. They're not isolated. They're all connected to each other. Going further, if you have a companion app, the companion app should be talking to these devices. They're all connected somehow. The question is, how do you get them connected? Well, you could use something like Bluetooth to talk to each other. But if your devices aren't physically close to each other, but they need to communicate with each other, what do? How do you provide a way for these devices to communicate with each other? And that's where I think Firebase comes in handy. Firebase can be the backend where all of your devices, your apps on your phones and your apps on your devices can all talk to each other through Firebase services. And it's pretty easy to do this, I think. So who here has used Firebase at all? Okay, we have a few. So so those of you who've used Firebase, you already know it's Google's mobile application development platform. It was designed for mobile apps specifically. Now, an Android thing isn't really a mobile app. I mean, it might be a mobile device, but because it runs Android and because it has Play services on it, it also has Firebase on it because Firebase is delivered through Play services. And it turns out there's a lot of features in Firebase, but only some of them are supported for Android things. So the ones that are being underlined here are actually supported for Android things. There's an SDK. You can compile it into your Android things app just like you would a mobile app. There's really not a whole lot of difference from a coding perspective. One of these features in particular is not an SDK, and that's Cloud Functions. Cloud Functions is a backend service, so you can write and deploy JavaScript or TypeScript code to run on Google service, and it's serverless. Has anyone heard the word serverless before? Okay, a couple people. So serverless programming does not eliminate servers. There's still servers. There's still a backend. But what you don't have to do is manage those servers. You don't have to know about those servers. You don't log into them. All you do is write and deploy code. And then that code triggers in response to events that are happening within your project. It runs in a managed Node.js environment. So Node.js is a very, very common backend infrastructure. And if you're using HTTP transactions, there's Express.js. So that's all built into it. Who here has done any sort of JavaScript at all? Anyone? Oh, okay, a few. So usually at an Android conference, most people know Java and Kotlin. They don't do JavaScript. If you want to write code for Cloud Functions, now is a really good time to learn JavaScript. In fact, I would recommend learning TypeScript because TypeScript is a lot like Kotlin. It adds a typing system to JavaScript, and it looks and feels a lot like Kotlin. So the thing I built uses these Firebase features. So I use Firebase Authentication to get users logged in to the companion app. I use Cloud Firestore. Cloud Firestore is a cloud-hosted NoSQL database. I use Cloud Storage. So Cloud Storage is also a cloud-hosted file storage. So if you upload files, you can store them in Cloud Storage. Both Cloud Firestore and Cloud Storage scale massively. So I think with Cloud Storage, you can put exabytes of data in there. I can't even in my mind imagine how big an exabyte is. I know kilobytes, I know megabytes, I know gigabytes, and then terabytes. But after that, I mean, it's even bigger than that. It's hard to conceive, but they scale massively. Cloud Firestore also scales massively as well, so you can put as much data as you want into it. I'm also using Firebase Cloud Messaging to send push notifications between devices. So this works equally well on Android things as it does in a regular Android app. And of course, I use Cloud Functions, and I'll say a little bit more about that. That's actually the key product in the thing that I built. You can also use Crashlytics for crash reporting. So if you're writing code on an Android thing and it crashes, you can use Crashlytics just like you would in a regular mobile app to receive notifications of those crashes. So what is the thing that I actually built? You're probably wondering. I built a doorbell. Now, a doorbell is a pretty simple thing, right? Everyone knows how a doorbell works, right? A guest approaches the house, you push the button, something rings, the owner of the house is notified there's a guest, and then they can come answer the door. It's pretty simple, right? But we can improve upon this, right? Doorbells can be made digital, and that was my experiment. So the way that my Android Thing project works is first the user rings, or the guest of the home rings the doorbell. This would be the Android thing, is the doorbell. It takes a picture of you. And then what it does is it sends that picture to the owner of the home so they can see who's at the door and then choose to let them in or not let them in. And then if they choose to let them in, it will unlock the door. Now, if you're using a rusty padlock on your house, I strongly recommend you upgrade your security system. So here's what the entire system looks like. This is the entire system diagram for all of the Firebase features that I'm using. Now there's a lot to unpack here, and I'll go through it one by one, but you can see there's a loop between the Android thing on the left and the companion app on the right. So the first thing to do, obviously, is to just capture the picture. So you remember that picture I showed you of my development device. There's a camera attached to it through a ribbon cable. So what I was able to do is capture a picture that way. Now, capturing a picture is really easy. You can use the Android Camera 2 API because Android Things runs Android. It has all the same APIs as normal Android, so you can use the Camera 2 API. There's very little documentation for this, but there is some sample code, and so I adopted that sample code. But I discovered there are some problems with this sample. First of all, camera previews, the camera sample will render a preview to the screen using a texture view. If you don't know what a texture view is, basically a way to draw directly to the screen. But I found that it's kind of slow. And the reason why texture view is slow is because my Android thing does not have a GPU. The GPU is very important for drawing lots of tiny triangles, which is what a texture view wants to do. It wants to do basically texture manipulation. But without a GPU, it's very slow. So I took this code and I ported it to use Surface View instead. And Surface View is very similar to Texture View, except it has a very much more limited API. Either way, you can draw to, you can have the camera API draw to one of these surfaces. The other thing I had to do was I removed the code that depends on autofocus. So if you look at the sample code, the sample code assumes that a camera has autofocus, and you know how autofocus works, right? What happens is when you go to take a picture, if it's blurry, the camera will refocus and try to find the thing that you want to take a picture of. But the camera that I had hooked up doesn't have autofocus. So the camera sample didn't work, so I had to remove all the code that dealt with autofocus. In a perfect world, portable camera code should check to see if autofocus is enabled, then use it, else don't use it. But I just ripped all that code out. So that was the first thing I had to do to get this project to work, is adapt this Camera 2 sample to work on Android things, or at least my Android thing. So after we capture the picture, what do we do? Well, we can upload it to cloud storage. Cloud storage is very commonly used for what we call user-generated content, so like pictures and GIFs and videos and sounds and things like that. So how do we do this? How do we write some code to upload that picture to cloud storage? Well, it's pretty easy. Here's a method. This is all Kotlin, so you can use Kotlin on Android things just like you can on a regular device. So what's happening here is what I do is I build a date format. So the unique ID for this image is formatted by a simple date format. So it's year, month, day, hours, seconds, as you would normally expect. And then I build a path to that. And this is the path within cloud storage where the file will be uploaded. So I reach into the Firebase Storage API and I get a reference to that path. And with that reference, all I need to do is call put file on it. That's it. So the file, so presumably the picture I took from the camera gets saved to disk. I could to a URI, and then I call put file. And that's it. That's all you do with this. It's like 3 lines of code to write a file into cloud storage. So put file returns a task. It's asynchronous, and that task will have its on-complete or its success or failure listeners called when the upload is done. And by the way, the SDK is doing a lot for you. It's actually managing things like retries. So if it fails, it'll automatically retry in the background. The SDK is managing all of the difficulty of dealing with cloud storage behind a very simple API. So in cloud storage, in the Firebase console, this is what it looks like. So you can see I have a record of a bunch of different rings. And the picture over there, that's not an interesting picture. That's a picture of the ceiling of my basement. I should have put something more interesting in there. But you can see in the Firebase console all of these files getting uploaded. So after we upload to cloud storage, we still need to get it over to the device. So how do we do that? Right? How do we let the device know? Well, what you can do with Cloud Functions is write a trigger that responds to uploads in cloud storage. So I can have this function, a bit of code that gets executed every time something gets uploaded to cloud storage. And what I do with that is, firstly, I'll write a record of this ring of the doorbell to Cloud Firestore. Now, how do we do that? Well, here's some TypeScript. So now I'm running backend code in Cloud Functions written in TypeScript. So what's happening here is I'm using the Firebase SDK for cloud storage, or sorry, for Cloud Functions. I'm going to use it and say I'm interested in storage events. And anytime an object is finalized, and finalization is the word for upload complete. So anytime an upload is complete, run my function called onRing. OnRing takes an object, type object metadata, and that object metadata object describes the file that was uploaded, so you can know its path and its size and other metadata about the object. And it returns a promise that indicates when all the work is done. So the first thing I'm going to do is reach into that object and get the name of it, and that's the path. So it would be like /pictures/ whatever that date format string is. Then I'm going to pull the base name out of it, and that's just the ID. That's the year, month, day, hours, minutes, seconds. So with that ID and with that path, I'm going to create a ring object. I'm going to give it an ID, the current date, and the path to cloud storage. And I'm going to go ahead and just write that to Firestore. So in Firestore, there's a collection called rings. And who here has used Firestore already? Anyone? No one? Okay, we can do the code lab after this. You can learn all about Firestore. So I'll tell you a little bit about Firestore. Firestore forces you to organize your data in terms of collections, and you have documents within that collection. So what I have is a collection called rings. I'm going to create a document in it with the ID of the ring, and then I'm just going to write that ring object right into it. Very simple. It's just one line of code to write a document in Cloud Firestore. This is what it looks like in the console. So if I want to interpret this from left to right, we have a collection called rings, and within that collection there's a number of documents, each with a unique ID, and that document that I wrote with the last line of code has a date, an ID, and an image path in it. It's pretty straightforward to do. So after I've written the record of that ring to Cloud Firestore, the second thing I'll do in my function is call out the cloud messaging, and then cloud messaging will notify the device of the ring. So here's the rest of the function. So I showed you before the beginning of the function that wrote to Cloud Firestore. Here's the second part of the function. What I'm going to do is build a payload, and this payload has a notification and a data part. The notification part describes what the notification will look like on the device. So most of you know Android, right? In the notification curtain, you'll have a title and a body and what to do when someone clicks that notification. So this click action is actually an Android action. So in Android, when you have an activity, you can have an intent filter in there. And in that intent filter, you can specify an action. So if you have an activity in your app with an action of COM, hyperware, doorbell, answer ring, what happens is when this notification is clicked, it'll go ahead and launch the activity in my app. And there's also an ID. So in the data payload, I'm storing the ID of the ring, and that's that date formatted string. And then with this payload, I'm going to use the FCM SDK. I'm going to send it to a topic called rings. So the way Firebase Cloud Messaging works is you can send messages to individual devices, or you can send messages to topics. And the way a topic works is you can have subscribers to a topic. So every app that's subscribed to the topic rings will get this message and be notified that someone is at the door. So here's where we're at so far. After Cloud Messaging kicks in, it's going to notify the companion app. Now, how does this work? Well, the way FCM works is it's going to ask the app, are you in the background? An app that's in the background has no visible components. No activities are showing on the screen. So if this app is in the background, meaning it's not visible, it's going to display a notification in the Android notification curtain. And then if someone clicks that link, it's going to launch the activity that displays the UI for this app. And it's going to pass the ring ID to it. But if the app is not in the background, meaning the user is actually using it at the current time when the notification arrives, it's going to invoke a service. And this service gets to decide what to do with that notification. So there's going to be there's a callback in there called onMessageReceive. It will receive the message for the notification, and you get to decide what you want to do with it in there. In my case, I just start the ring UI and I pass the ring ID in. So there's two ways for a message to get to your app, either in the background or in the foreground. I handle both. So the way you handle this in the app itself is you write a couple services. So when the app launches, it's going to invoke something called an instance ID service. So I have a service that I subclass. It's subclassing Firebase Instance ID service, and it has an onToken refresh callback. And this token refresh will be called very quickly after your app launches for the first time. It's going to be delivered. This is your first opportunity to register to subscribe to that topic. So this is our first earliest possible moment when we can get the app subscribed to the rings topic. And then there's a second service you can implement. It's a subclass of Firebase Messaging Service. And like I mentioned before, when a message arrives, the onMessageReceive method will get called. Then you can look inside it and say, does it contain a ring ID? If it doesn't, then I don't care about it. But if it contains a ring ID, then I do care about it. I'm going to build an intent to the activity I want to launch, put the ring ID as an extra, and then go ahead and just start the activity. So pretty straightforward. Not very many lines of code to handle messages. The SDK makes it very, very easy to do so. Then inside the activity itself that gets launched, in the onCreate, I'll reach into the intent, get the extras, pull the ring ID out of the extras, and then handle it from there. So just to remind you, here's the data in Firestore. Remember, we have a collection called rings, documents within that, and the record of the ring itself. So what I want to do in my activity is get that unique ring ID and load this data out of Firestore so I can display it. And when I display it, it'll look something like this. Very simple UI. The homeowner gets to decide, yes, let them in, or no, don't let them in. So I want to build this UI. So how do I do that? Well, in the app, the first thing I'm going to do is read from Cloud Firestore to get a record of that ring, that document that describes the ring. And the second thing I'll do is download the picture from cloud storage. So let's see what that looks like in code. So the first thing I'm going to do is use the Firestore SDK to access that collection called rings, and then pull a document out of it with the ring ID, the unique ID that came from the cloud message. Then I'll call get on that reference. Get is asynchronous. It will return a task. And if the task is successful, I'll get a snapshot of that document. So now I have that document with 3 fields that you saw in the console. And what I'll do is I'll have it convert that to an object or a class called ring. So I'm not showing you the code for the ring class, but if it has fields that match the fields in the document, the SDK will automatically populate the ring object with the fields that you've defined. You don't have to write any code for that. All you're saying is, I know there's a ring object in there, just give it to me, assign all the fields. When that's done, I'm going to reach into Firebase storage and get a reference to the image path that was stored in the ring object. And then I'll use glide to load it. But who here has used glide? Anyone? Okay, so we got a handful of people using glide. Glide is pretty easy. What it does, its sole purpose in life is to load images from some source and put them in an image view. That's what it does really, really well. Now you'll notice here I'm using the Glide SDK to load a Firebase storage reference. That ref object, it's not a URL, it's a reference. Normally you use Glide to load a URL. So if you know like the HTTP URL of an image, Glide will load that and put it in an image view. But here I don't have a URL, I have a Firebase storage reference. So how does it know how to actually load that? I mean, that logic isn't built into Glide. Glide doesn't really know anything about cloud storage. So what I can do here is add a module, a Glide module to my code. So what you can see here, there's a class called my@glide_module. Subclass is glide module, and it's annotated with that annotation glide module. What this does is the glide annotation processor will pick up on this class at build time and retain a record to it. So when glide initializes, it knows here's a module that I need to load on initialization. So when the register components callback is called, what I'll do is take the glide module registry and I'll give it instructions on how to load images from cloud storage. This is only really 1 line of code. Well, it's wrapped to 2 lines. How does it know? Well, there's a library out there called Firebase UI. Firebase UI is an open source library that makes it really easy to deal with your data in Firebase. So this Firebase image loader right here, that's a class provided by Firebase UI, and it has all the smarts to know how to download an image from cloud storage and make it available to Glide so it can load that into an image view. So really, you've just written, what, a couple lines of code here, and now automatically you have the ability to copy data from cloud storage into your app quickly and easily. So here's where we're at so far. So we've rung the doorbell, we've uploaded the cloud storage, we've written the cloud functions trigger that both writes to Cloud Firestore and sends a message. So where do we go from here? We need to complete the loop and get back to the device to decide whether or not it should unlock the door. So the next thing I'll do is the app will write the answer to Cloud Firestore. So remember there was that document that had the ID, the date, and the image path. Well, I'm going to add some new data to that document. And I'm going to add the disposition, which is true or false, basically. Do we let the user in or not? Or do we let the guest in or not? So here's what you can do in your app. So assuming that the disposition, the true or false coming from the click in the UI, what I'll do is I'll take that reference to that document. This is the reference to the document in Firestore, and I'll update it. And I'll put a new object in there called answer. And that answer has 2 properties: the UID of the user who's using the app and the disposition, the true or false. And then after that, what will happen is I'll have an incomplete listener or a failure listener. It will basically always complete. So when that's done, what will happen is this document will be updated with a new object in there. And you can see the disposition and the UID. So this document now contains new data that is the intention of the homeowner, what they want to do. So we've written that into Cloud Firestore. So now what's next? Well, in order to keep this data moving through the system, I'll write another function using Cloud Functions that will trigger in response to that document being updated. So when that document is written with an answer, I can now write code, back-end code, that responds to that. And then what it'll do is it'll send a message to the device using Cloud Messaging. So what does this look like in code? Well, now we're back in Cloud Functions. We're writing TypeScript again. And what we do is use the Functions SDK to say, I'm interested in Firestore events, and I'm interested in documents that match this pattern. So anything in the rings collection that matches a ring ID, I want it to call my function called onAnswer. And this onAnswer method will get called anytime a document is updated in the system that matches this pattern. So my onAnswer method, my onAnswer function is going to receive an argument called a change. And this change object contains document snapshots. And it contains a before and an after document snapshot. So I'll get the ring ID out of the change, and I'll get the ring object, the state before of the change, and I'll get the state after the change. So the before is not going to have the answer. The after document will have the answer in it. But I don't want to respond to any change to this document. I'm only interested in changes where an answer has been added. If there's any other update, I don't care about it. I just want to know if an answer's been added. So I do a little Boolean logic there to figure out if this is a document that I'm interested in. If it's not interesting to me, then I'll just terminate the function and do nothing. But if it is interesting, if an answer has been added, I'll do just like I did before, and I'll build an FCM payload. And that payload contains a data portion, which is the disposition, the true or false, and the ring ID, so the device knows which ring the homeowner is responding to. What I'll do is I'll use the FCM SDK just like before, and I'll send a message to a topic called answers. Now remember, there was a rings topic, which is what the app is subscribing to. I also now have an answers topic, which is what the Android thing is listening to. And I'll send it to payload. And that's it. I mean, that basically pushed the data from Cloud Firestore to the Android thing via Cloud Messaging. So here's where we're at. We've almost completed the loop here. So now what do we do with Cloud Messaging? Well, Cloud Messaging will notify the Android thing. And the code to handle this in the Android thing is just like the code that handles messages in the app. They're identical because it's all using the same SDKs. So this should look very familiar. We subclass Firebase Instance ID service, and when we have a token refresh message, we'll subscribe to the topic called answers. Now we can receive those answers from the companion app. And to handle the message, we'll subclass Firebase Messaging Service just like before. We'll get a call to onMessageReceive just like before, and we'll reach into the message and see if it has a disposition. And if it does, we'll build an intent to the activity we want to invoke on the Android thing, put an extra in it with the true or false, and then start that activity. Now, with Android things, you have activities and fragments and services and broadcast receivers just like you do on Android. It's the same infrastructure. So if you know how to write code for Android, you basically already know how to write code for Android things. In fact, they can share code through libraries. So here's the loop. So now when Cloud Messaging finally notifies the device, it can decide whether or not I want to keep the door locked or unlock the door for the guest. So that completes the loop. There's one other thing in the app. In the app, I maintain a record of all of the rings that have happened through the system. And of course, if you have a scrolling list, you use a recycler view, right? Everyone here knows recycler view? Most people know recycler view? Okay, good. You all should know recycler view. This is basic Android. You know, recycler view is very efficient, but you end up writing a lot of code to get a recycler view to work. You have to write your own adapter, right? Turns out writing adapters is not really very fun. There's not much to say about it. But this is very easy with Firestore. Firebase UI, that open source library I mentioned before, has a utility in there called Firestore Recycler Adapter. And what it can do is take a Firestore query and automatically take that query, get the results, and help build the UI for your app. This reduces a lot of the code you have to write. It's very, very easy to do this. So that's one of the things I like about using Firebase, is that there's all these open source libraries that make it very, very easy to get very basic work done. So you might be wondering, what about security? You know, we're depending on the security of this device to keep people out who should stay out and to let people in who should stay in. Now, someone could hack the system and then unlock your door remotely, right? So if you're actually wanted to do this in your house, you probably need to give some thought to security to make sure you don't have a situation where anyone can unlock your door by hacking the system. So right now you'll notice that the Android thing can write directly into cloud storage. That effectively rings the doorbell. Once you've written into cloud storage, that's a ring. Also, you'll notice in the app is reading from Firestore, reading from Cloud Storage, and writing to Cloud Firestore. That write to Cloud Firestore can effectively unlock your door. So if anyone can write to Cloud Firestore, anyone can unlock your door. This is a security problem, right? So you'll need to lock down your system to make sure that only valid devices can write to Cloud Storage, and only valid devices can write to Cloud Firestore. So who here has worked with security rules at all? Firebase, Cloud Storage, a little bit? Okay. So when you create a new project, typically you're asked to do something with security rules. This security rule for Cloud Storage allows anyone to read and write all paths within Cloud Storage. A lot of people, including myself, when you create a new project, just set the security rule so that everyone can read and write. It's an easy way in, right? You can just start reading and writing right away. You don't have to do any extra work. But this is bad. You should never ship an app like this. Never ship an app where you have everyone reading and writing your cloud storage. Same thing with Firestore. These Firestore rules let everyone read and write every document in your system. This is bad, right? If anyone can do this, then anyone can unlock your door. So don't ever ship an app like this. You always need to be thinking about security rules for shipping apps. So what do we do about security here? I will admit it's easy to get started without security, but when it comes time to ship the app, you should at least have something in place to prevent unauthorized users from reading and writing data. So minimally, make sure that users are authenticated, that you're using Firebase Authentication, and only authenticated users can read and write data in your project. I think you should also consider validation rules. So validation rules is a special kind of security rule that restricts the kind of data that you can put into your database or cloud storage. So for cloud storage, you could say only allow images that are JPEG, and only allow images that are within a certain size. So you can be more specific about what kind of data can be written and read from Cloud Firestore and cloud storage. So there's some references. Be sure to familiarize yourself with these documents. When it comes time to ship an app, definitely lock down your database. The other thing is, I've mentioned that you have to get users logged into your app. So I use Firebase Authentication for that. That hooks into the rest of, that hooks into Firestore, that hooks into cloud storage. It's pretty easy to use, but authentication implementation is very hard. So imagine what it would take to write the code to get someone logged into your app. It's actually a lot of code to do that, and it's really easy to get wrong. I don't recommend that you write this code yourself. Instead, you can use Firebase UI. Now, this is the third time I've mentioned Firebase UI so far. First time I mentioned it was, what was the first time that I mentioned it? Well, the second time I mentioned it was the recycler view. So it made working with recycler view very easy with respect to pulling down the data from Cloud Firestore. So Firebase UI also makes it very easy to deal with authentication login. So all you need to do is add this one dependency to your app. And if you have a sign-in button in your app, this is what you do to kick off that authentication flow. It's just a few lines of code. It's very, very easy. So you start an activity for, so assuming that you have a button that gets clicked, you can start an activity for a result, and you say, hey, Firebase UI, get an instance, and I want to create a sign-in intent, and then I want it to be able to log in with Google. That's what I'm saying here. Then I build that intent, and I just start the activity. And then Firebase UI takes over and walks the user through getting signed into the app. It does all the hard work. All you do is say, hey, start, and then it handles everything. So if you're logging in with Google, it will pop up a dialog, and the dialog will be populated with all the users who have an account on your phone. When you select that user, then you'll get a callback from the activity result, and you look into the activity result and just check to see, was there a sign-in successful? If there was, then you know the user's logged in. That's it. All you do is start an activity and then receive its result. And Firebase UI does all the hard work in the middle. So getting someone logged into your phone app is really easy, right? For devices, for regular Android phones and tablets, it's very easy to get logged in. But the thing needs to get logged in too. The Android thing is going to be reading and writing data. It needs to be logged in. But how do you do this? It doesn't have a normal UI. You can't make all of your guests sign into your doorbell in order to read and in order to ring the doorbell. That's kind of silly, right? It turns out that the UI for the various provider logins aren't supported on Android things. So you can't do a normal login flow with Firebase UI on Android things. So that's unfortunate. There's a further complication. Your Android thing may not even have a screen. A lot of Android things may just have like an LED readout or just a simple multi-segment display. There may not be a touch screen at all. There may not be anything to see. So how do you get a thing logged in given that it doesn't have a screen to interact with? That seems kind of weird, right? You could use anonymous login. So Firebase Authentication supports something called anonymous login, where the user doesn't have to be logged in. They don't have to interact with the app. They get a temporary anonymous account. But this isn't a great solution for Android things, I don't think. Anonymous login is for when you want to get people logged into your app very quickly and then upgrade them to a fully authenticated account later. So they might log in initially anonymously, then upgrade that to a Google account or a Facebook account or a Twitter account. So I wouldn't use anonymous login here for Android things. The best way to get an Android thing logged in is to get proper user credentials somehow for a real login with a real user account behind it. But like I said, if you don't have a screen, how do you get logged in? Well, the solution that I came up with was to share an authentication credential from the companion app to the thing. There's a token. So the idea is to get an authentication token from the app into the Android thing so the Android thing can read and write the data. But how do you do this? We can't use Firebase because Firebase is locked down. Remember, we don't want unauthenticated devices to read and write data. So if the thing isn't authenticated yet, we can't use Firebase as a data exchange point. So what do? Well, there's something called a Nearby API. Google's Nearby API basically does device-to-device communication, direct communication. And it's really easy to use. There's two forms of messaging within Nearby. First is Nearby Messages, and the other one is Nearby Connections. And I'll talk about it real fast, how they're different. So if you use Nearby Messages to communicate between devices, it's basically a pub-sub model. So one device publishes data, and the other device subscribes to the data. So if you were trying to get a token shared from your app to your device, the app would publish, and the thing would subscribe, and then they can share a small payload through that. The devices are paired using a combination of Wi-Fi hotspot or Bluetooth, Bluetooth low energy, or near ultrasonic radio. So somehow the two devices will figure out that they're near each other, and then they can exchange a token. And the data payload actually happens through a Google Cloud project. So in this case, they're actually using the Firebase project, but a very special channel of communication between them to get that data from one place to another. Now I found that this Nearby Messaging didn't work with Android things 0.6.1, but the current version, 0.7.0, it does work, and I was very happy about that because this is the easiest way to get data shared from your app to your thing. The other API that's provided by Nearby is called Nearby Connections. And this is a little bit different. It's direct peer-to-peer, high bandwidth, low latency connections. So you're not going through a server. No internet connection is required. You're literally just sending data directly between two devices. And this data exchange happens over Wi-Fi hotspot or Bluetooth low energy. No internet is required. The only problem is it's a lot of code to show here. Nearby Connections requires a fair amount of coding. Nearby Messaging is very easy, and I'll show you that. So if you wanted to share data between your app and your thing using Nearby Messaging, all you have to do is use the API to have one device be a broadcaster. So one will have a strategy that broadcasts. And you build an option where you use, you create a publish options object and you set the strategy in there, and that's it. Then you use the Nearby API to get a client, you define the message that you want to share, and then you call publish, and that's it. So the app that wants to do the publishing, to publish a small payload, just has to set a strategy, a publish options, and then just call publish. That's it. That's all there is to it. Now, on the receiving side, the subscriber looks almost exactly the same. So you have a strategy that is discovery mode scan instead of publish. So this is the receiving end. And then the receiving end, we create a subscribe options with the same strategy. And then we grab a hold of the client. We create a listener that gets invoked when it comes within range of the other device. And all you do is subscribe. And that's it. And that's when the device gets in range, it will receive the token. Was I being notified? What was that signal back there? I'm sorry?
You're out of time for 3 minutes.
Okay. Well, I'll go through this quickly. Let's see. So once we have the token in place, then in the app, in the Android things device, we'll get that token. We'll use the Google Auth provider to get a credential for that token, then pass that to Firebase Auth to get logged in. So what we've done is we've shared a token from the app to the device, and the device can use Firebase Auth to get logged in with that token. And then we have the record of the user that actually logged in. Okay, nearby connections, a lot of code. I can't show that here. But here's the entire system diagram. And what we just did with nearby is create this whole, we bypassed Firebase to send that authentication token. But now we have a secure system because everything is logged in, both the app and the thing. Now there's a bunch of things that can be improved, but since I'm out of time, I'm going to go through it real fast. Yeah, oh no. There's basically, pay attention to security. You have to pay attention to security. Yeah, this project needs better security, it needs better Bluetooth pairing. I can add all kinds of features. I can do facial sentiment detection. I can do I'm just going tearing right through this. I can do speech to text with Google Cloud Speech API if I'm writing in Cloud Functions. I can create digital keys for my logs. So imagine you have a guest app where the guest can effectively interact with the doorbell through a whole different app. Or I can print out QR codes to give to a guest, and then maybe they can use it one time by showing it to the camera. So there's a lot of things you can do here. It's not just a simple doorbell. It can be a lot more. So that's all I have time for. Thank you.